This is the Algebra 1 test review for Unit 4. We have been studying systems of equations, so that's what this review is going to cover. So let's take a look at the first 4 questions here. We need to determine the number of solutions that each system of equations has, either 1, none, or infinite. And it's telling us we don't need to solve these, we just need to determine how many solutions. So let's look at the first set of equations. Y equals 2x plus 2, y equals 2x plus 2. Well, they are the exact same equation, and so that would be infinite solutions. If we were to graph those two lines, you would have one like this, and another one would just graph right on top of it. So every x and y would be identical. Okay, on number 2, let's look at it. These two equations have different slopes. So we know if they have different slopes and we were to graph them, they would graph like that, and there would be one solution where the two lines intersect. On number 3, we see that these two both have the same slope, but different y-intercepts. So if I were to graph these two lines, they would look like this. Oops, that second one not so good. Let's try it again. Like that. The lines would be parallel. They're never going to intersect, so there's no solutions. And then finally, the last two, similar to the first one, these are two equations that are exactly the same. And so if we were to graph them, they would graph right on top of each other, and that would be infinite solutions. Okay, now the next two we need to solve. So when we're solving systems of equations, we need to look them over and decide what might be the best method. Now remember, we've learned 4 ways to solve systems of equations. We can do substitution. So substitution is a good method if one of the equations says x equal or one of them says y equals, and then we can plug that into the other equation. We could use elimination. And elimination is a good method when we have a number on top, say 2x, and then the second equation has the exact opposite. Or even if you had something like this, let's say you had 2x on the top and you had negative 4x on the bottom, we could take the top equation and multiply it by 2, so we would have a 4x and a minus 4x, like that, and then the variable would eliminate. So that's elimination. Then let's see here. What else? If you had a coordinate plane and you were able to graph your equations, you could find the intersection point. And then finally, if your two equations are both solved for y, you could put those into y1 and y2 in your calculator, then hit graph, and then do second, trace, 5, enter, enter, enter. And you could solve it that way. So those are the 4 methods that we've learned. So let's take a look at these two. And on number 5, I'm going to suggest that we use substitution, because this first equation says x equals, and since x equals 2y minus 3, I'm going to take 2y minus 3 and substitute it for x in the second equation. So I'm going to say, instead of 3 times x, we're going to do 3 times 2y minus 3 minus 5y equals 7. Now we're going to distribute, so we have 6y minus 9 minus 5y equals 7. And now notice on this equation, we have a 6y here and we have minus 5y there. So those are like terms and they're on the same side of the equation, so we can just combine those. 6 minus 5 is 1y, so we have y minus 9 equals 7. And now let's add 9 and we get y equals 16. Okay, now that I know that y equals 16, let's go back to our original equation and plug that in to find x. So we have x equals 2y, so instead of y, we're going to put in 16 minus 3. So that's 32 minus 3, so x equals 29. So let's write our final solution as a coordinate pair 29 comma 16. And we're done. Okay, now on number 6, we need to look this over and think, what could we possibly do to solve this? I think I'm going to do elimination. And the way I'm going to do elimination is to take this top equation and I'm going to multiply it times -1. Now when you multiply by -1, the only thing that changes is the sign. So positive 2x now becomes negative 2x. Negative 2y becomes positive 2y. And negative 6 becomes positive 6. So that's my top equation. Remember, if you multiply something on one side and do the same thing to the other side, you haven't changed a thing. So we've multiplied everything by -1. Now the second equation, I'm leaving exactly the way it was. 6x minus 2y equals 6. Now let's combine the two equations. So I have 6x minus 2x right here is 4x. These cancel out. And 6 plus 6 is 12. Divide by 4, and you get x equals 3. Okay, now that I know that x equals 3, I'm going to put that back into the original equation. So instead of 2 times x, I'm going to 2 times 3. So we have 6 minus 2y equals negative 6. So now we're going to subtract 6 from both sides. So I have negative 2y equals negative 12, and I'm going to divide by negative 2, and y equals positive 6, because a negative divided by a negative is a positive. So 3 comma 6 is our solution. Okay, let's look at number 7. Okay, on this graph, we are given two lines that represent two different companies. So the line that's dotted represents Target, and the line that's solid represents Best Buy. And let's look and see what we can figure out from this graph. We can see that we're looking at the number of DVDs, and we're looking at how much they cost. So we're trying to figure out how much do DVDs cost at Target and Best Buy. So how many solutions does this system of equations have? Well, it has one solution. And how do we know? Because they're straight lines with different slopes and they intersect. What is the solution? And the solution is right here. And we would say that is 8, 50. Now, it says, what does this solution represent in this situation? Well, let's look. X represents the number of DVDs, and Y represents the cost. So this is X and this is Y. So we can say 8 DVDs cost $50 at both Target and Best Buy. Now, if you notice, after that point, after 8, the DVDs at Target get less expensive, and the DVDs at Best Buy become more expensive after 8. Now, before that, before you buy 8, Target was more expensive, and Best Buy was less expensive. So this was the turning point in it right there at $8.50. Okay, let's go to the next page. Maggie's coin collection consists of dimes and quarters. She has 53 coins and worth $7.85. How many dimes and quarters does she have? So it's define your variables, write a system of equations that can be used to for this problem. And then it says you do not need to solve it this time. So right now we're just setting it up. So remember, our let statements are going to be let x equal something and let y equal something. So we're going to let x equal what? We're going to let it equal dimes. That's what we have there first in the problem. And we'll let y equal quarters. Now we have two different equations. One's going to deal with the number of coins. The other one's going to deal with the money. So let's look at the number of coins. If x is the dimes and y is the quarters, then we can say x plus y equals 53. Now, I'll use green for the money. How can we do that? Remember, what is the value of dimes? Dimes would be worth 10 cents. So 10 cents times x plus 25 cents times y, which is the quarters, is going to add up to $7.85. Okay, let's look at number 9. It says, is 1 common negative 4 a solution to this system? You must show work to support your answer. So look, this is x, this is y. So what we're going to do is just plug in x and y into our two equations and see if they come out to be true. So we'll start with the first one. I'm going to go ahead and rewrite the equation up here. Negative 4x plus 2y equals negative 12. So I'm going to substitute 1 for x, and I'm going to substitute negative 4 for y. So negative 4 times 1 plus 2 times negative 4 equals negative 12. So this is negative 4. Positive 2 times negative 4 is negative 8. So minus 8 equals negative 12. And negative 4 minus 8 is negative 12. So it works for that one, comes out true. Let's try the second one. 15 times 1 plus 3 times negative 4 needs to equal 6. So we have 15, and positive 3 times negative 4 is negative 12 equals 6. So 15 minus 12 is 3 equals 6. Is that a true statement? Does 3 equal 6? No, not true. So that's 1 comma 4, negative 4 is not the solution. Okay, let's look at number 10. Okay, it says at the candy store, 8 chocolate bars and 4 peanut clusters cost $7, while 3 chocolate bars and 7 peanut clusters cost $5.10. How much does each peanut cluster cost? So it says define your variables, write a system of equations that can be used for this problem. Then we're going to have to solve it because we do have to actually answer the question. So let's do our let statements. So we're going to let x equal chocolate bars, and we're going to let y equal peanut clusters. I'm just going to write peanuts from there. And we have to do two equations. So 8 bars and 4 peanuts is $7. So 8 times x plus 4 times y equals 7. And then, let's see here, 3 chocolate bars plus 7 peanut clusters equals $5.10. Now we need to look this over and think, what would be a good way to solve this? Now, we did some of this in class today, and I had some folks that solved them for y and then put them in their calculators, but I will tell you, if you do that, it doesn't come out with very nice numbers. You end up putting in some very weird fractions into your calculator, like you end up with $5.10 over 7. You've got to put that in your calculator. So, but you could do that if you wanted, solve them for y. But I think what I'm going to do is use elimination again. But I have to think this out. I guess what I'm going to do here is I'm going to take the top equation. I'm going to take the top equation and multiply it times 7. And I'm going to take the bottom equation and multiply it times negative 4. Now let's see what that would do for me. if we multiply the top equation by 7, we're going to end up with 28y right here. And if I multiply it by -4, I'm going to end up with minus 28y on this one. So that's why I can use elimination on it. So let's go ahead and multiply both sides by 7. And so we get 56x plus 28y equals $49. And then the second one, we get negative 12x minus 28y equals negative, let's see here, negative $20.40. 20.40. Okay, now let's combine the two equations. 56x minus 12x gives you 44x. The 28's cancel out. And then $49 minus 20.40 gives you 28.60. Divide by 44. And x equals 65 cents. So x is the chocolate bars. So that doesn't help me because it asks us for how much is the cost of a peanut cluster. So don't get suckered into picking 65. That's the wrong answer. Okay, so what we want to do is figure out the peanut clusters. So we're going to plug in 65 cents and then figure out. So I'm going to use this second equation right here. So I'm going to do 3 times 65 plus 7y equals $5.10. So we get $1.95 plus 7y equals $5.10. Subtract $1.95 and you get 7y equals $3.15. So now we're going to divide each side by 7, and I'm going to go over top this other question. Divide by 7, and 3.15 divided by 7 is y equals 45 cents. So that's the cost of your peanut cluster right there. So it's letter C. Okay, let's go on to number 11. Okay, number 11 says Nick and Laura went to a store to buy DVDs on sale for $5 each, tax included. Nick purchased 4 more DVDs than Laura purchased. Together they purchased 14 DVDs. Which system of linear equations can be used to determine N, the number of DVDs Nick purchased, and L, the number of DVDs Laura purchased? Okay, so we have two things going on here. We have the number of DVDs that they purchased together, and that is 14. And then the other thing we have is the relationship between the two. Nick purchased 4 more than Laura did. Now, I always find it helpful. Well, first of all, let's figure out this part right here. Together they purchased 14 DVDs. And in this question, they're using N for Nick, the number that Nick bought, and L for the number of DVDs that Laura bought. Okay, so we have Nick and Laura, and so together they purchased 14. So that would be N plus L equals 14. So let's look at our equations. It's included in that one. It's included in this one. And C, it's not there. And it's included in D. So we can eliminate C, and the other 3 are okay. But now we need to figure out the second equation. I think it's always maybe easier to write, here's L for Laura, here's N for Nick. And think about it. It says Nick purchased 4 more DVDs than Laura purchased. So if Laura purchased, let's say 5 DVDs, then that means Nick purchased how many? If he got 4 more, then he got 9. So what's the other way we could do it? What if Nick purchased 12 DVDs, and he purchased 4 more than Laura. That means Laura purchased 8. So if we started with L, we could do L plus 4 would equal Nick, right? But if we started with Nick, we would say Nick minus 4 equals Laura. So we want to see if one of these two equations is showing up on the second equation. So this one says Nick equals Laura minus 4. Well, that's not right because it needs to be Nick equals Laura plus 4. So that one's wrong. And then this one says Nick is equal to 4 times Laura for letter B. So that's wrong. So it's got to be letter D. So we see here Nick is equal to Laura plus 4. So that's the right answer. Okay, now let's look at number 12. I'm going to erase some of this. The equations of two lines are 6x minus y equals 4 and y equals 4x plus 2. What is the value of x in the solution for this system of equations? So you have to look at this and decide how do you want to solve it. And I'll tell you what I'm going to do. I'm going to leave the second equation, y equals 4x plus 2. And the first equation, I'm going to solve it for y so that it says y equals. So we have 6x minus y equals 4. So I'm going to subtract 6x on both sides. These cancel out, so I have negative y equals negative 6x plus 4. Now I wanted to say y equals, not negative y equals, and so we have to divide everything by negative 1. And we have a shortcut for dividing by negative 1. We just change all of the signs. The negative y becomes positive, the negative 6 becomes positive, the positive 4 becomes negative. And so now here's our two equations. Y equals 4x plus 2, y equals 6x minus 4. And so I'm going to put one of them into y1 on my calculator. I'm going to put the other into y2. And then I'm going to hit graph, and you're going to get two lines, and you're going to find the intersection point. Second, trace, then number 5, and then enter, enter, enter. And when you do that, you find that x equals 3 and y equals 14. So if that's the case, it says what is the value of x? X is equal to 3, and there it is. So I'm going to stop right there, and we'll call that part 1 of the algebra review, and you can look for part 2 to get the second half of the review.